In this video, we're going to briefly talk about gradient descent, and we'll just show a very simple way of how you can implement it in pure Python and just have a look at some of the visualizations. So firstly, we're going to take a problem just by creating something from make regression out of scikit-learn datasets. And I'm just doing it by taking the first column and the second column and adding them together to create our target. I'm just making it two-dimensional because then it's just a little bit easier to reason with when you create the plots and whatnot, because it's easier to visualize things in 2 or 3 dimensions, and it's very hard when you have many predictors. So let's just have a look. I'm going to create a regression problem with 2 features. And we're just going to create a data frame where the columns are C0 and C1, which is why I've just hard-coded it here. Of course, in practice, you wouldn't really do it this way, but it's just for ease. In this particular case, I'm going to, we're also going to define the error to be like mean squared error. So that's why there's a mean and square, mean squared, and this will be the error. And what we're going to do is we're going to create the linear regression by hand using pure Python rather than using scikit-learn. So firstly, let's plot out what the error function looks like. So I'm going to do a surface plot, and then you can have a look. So here in Plotly, we can see that this is what the error function looks like. So we have the y-axis and the x-axis, x1, x2, and the z. So in this particular case, I've defined things to be I've defined the z, so the height, to be the error, as you can see here, and x and y would be the first and second columns respectively. So you can see that what we want to do is minimize the loss, so we want the ideal loss to be around here. Okay, so how does stochastic gradient descent find this particular value? Well, we'll have to do some maths. I've just written it up here, but it's quite simple high school calculus. So in this case, we just take partial derivatives around a particular weight that we want, and it's fairly easy to write it out. So as part of stochastic gradient descent, we have a learning rate, which is basically just a Taylor approximation, and in this case, I'm just going to hard code it to 0.1, and I'm going to initialize the weights to be 0 for no particular reason. All right, and then how we update it to get the next value is we just have the learning rate, and we have the particular update that we want across the whole data set. Or generally in stochastic gradient descent, you actually take a mini batch, but of course we can be a bit greedy and just take it over the whole data set because it's sufficiently small. So here we can see that although we started with the points 0 and 0, you can see that what the next point gets evaluated in this case, and also the error. All right. The next thing we can do is we can, of course, just create all of these things to get the next point based on our previous point. So I have this function that's nicely wrapped up. And then we can just save all the results so that we can create another plot. So all of the maths is fairly simple if we consider it. So if you look at what this thing looks like, it's just 2 times the weights, depending on the target function, right, minus the actual result. So we can see that reflected over here, where this is the target function here, which is our linear model, and minus the actual label, which is a y. And this is where the 2 comes from when you differentiate, and the eta here is the learning rate. So that's the update, and this is how it's reflected in this function here. All right, so what does this look like when we select the arbitrary point and play it through? I have a Plotly graph down here which shows this, and we can see that's how it gets updated. That's the starting point, and eventually it just gets all the way down to the minimal. So this is just a short video to demonstrate visually how stochastic gradient descent works. Hopefully you learned something, and I'll see you next time.